Hello my dear students. Today we will learn the first lesson of trigonometry. Introduction to Trigonometry Chapter 8, Exercise 8A, page 241, MBOSE Maths Book Class 10. So first see what is the meaning of the word trigonometry. The word trigonometry has come from three Greek words. We can say this T-R-I, tri meaning three, and here is gono, that is derived from gonon, G-O-N-O-N, which means angles, and metry is measurement. Metry is measurement. So we can say, simply we can say three angles measurement. Generally, trigonometry deals with the measurement of sides and angles of a triangle. Next is coming trigonometric ratios. What are trigonometric ratios? There are 6 trigonometric ratios. Say we take a right triangle ABC, right angle at B, right angle at B. Then this angle BAC, simply angle A, and this angle ACB, simply angle C. This angle A and C, they are acute angle. It means they are less than 90 degree. If we take the angle A as theta, is a Greek word theta, then from angle A theta, the opposite side we call perpendicular, 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 or the opposite side, or opposite side, opposite side. And from right angle, our angle B is right angle. From here, the opposite side AC we call hypotenuse, hypotenuse, and the remaining side AB, that is our base, BASE, we can say adjacent side also, adjacent side also. Now, with respect to angle BAC theta, there are 6 trigonometric ratios. With respect to, we can say, with respect to angle BAC is equal theta. Theta is a Greek word. So with respect to angle BAC, there are 6 trigonometric ratios, 6 trigonometric ratios. These are, we can read as, number 1, sine theta, sine of angle theta, we call sine theta shortly. Sine theta, we have definition like this: perpendicular by hypotenuse. Here is perpendicular, perpendicular, perpendicular by hypotenuse. So if we see the figure, perpendicular is BC. We can write here for perpendicular BC, and hypotenuse is what? AC. So sine theta is actually the ratio between the two sides, perpendicular and hypotenuse, of a right triangle. Then number 2 is cos theta. Cos theta, actually cosine theta. Cosine theta, we call it cos theta, and we express cos theta as the ratio of base by hypotenuse, base by hypotenuse. So in figure, base is AB and hypotenuse is AC. So cos theta meaning cosine theta. Cosine theta is the ratio between the two sides, base and hypotenuse. If base is AB here and hypotenuse AC, it is AB by AC. And number 3 is tan theta. Tan theta we express as the ratio of perpendicular by base. So in our figure, perpendicular is BC and the base is AB. And next number 4 we can write as cosec theta. This cosec theta actually reciprocal of sine theta. Reciprocal of sine theta, it means opposite of sine theta. So this formula if we change, we can get the definition of cosec theta. It can be hypotenuse by perpendicular. So just we take opposite here AC and here is BC. So what we have said, cosec theta is reciprocal of sine theta. So if sine theta is perpendicular by hypotenuse, cosec theta is hypotenuse by perpendicular. And if sine theta BC by AC in this figure, then cosec theta is AC by BC. In the same way, reciprocal of cos theta is sec theta. So it is opposite of this definition, hypotenuse by base. So sec theta is the ratio between hypotenuse and base of the triangle. And if we look here, we can just make opposite. AC is up and this AB is down. And number 6 is cot theta. This cot theta is reciprocal of tan theta. So tan theta we have written perpendicular by base. So take the reciprocal, it will be base by perpendicular. Totally you can write. So we have here AB by BC. AB, changing this, AB up, BC down, AB by BC. So these are the 6 trigonometric ratios. So actually trigonometric ratios, they are the ratio between two sides of a triangle. So with respect to angle theta, so the three sides of the triangle, again let us see. From theta, if we go opposite, we get the side BC, that is our perpendicular or opposite side. And from the right angle of the triangle, if we go opposite, we get the hypotenuse, that is our AC. And the remaining side AB is our base. This is our 6 trigonometric ratios. And there is a simple way to remember this formula. Suppose if you remember one sentence like this, So this cot theta, it did not come. So cot theta is base by perpendicular. This is opposite of tan theta. So we write this base is up and perpendicular is down. So AB is up and BC is down. And let us know how to remember this formula very quick. There is one sentence is like this. Some people, it is an interesting sentence. People have curly brown hair, turn perfectly blue. So first three words from the sentence we separate like this, next three words we separate like this, and remain next three words. We underline the first letter of each word, S, P and S. So from here we get the formula S, this S for sine, and P for perpendicular, H for hypotenuse. We can write sine equal perpendicular by hypotenuse. From here, the first letter we underline C, B and H. So C for cos is equal B for base and H for hypotenuse. And next three words we underline the first letter of each word, then T for tan, then we have this P for perpendicular and B for base. This is the quick way to remember this formula. Just remember, some people have curly brown hair turned perfectly blue, and then the sum S for sine, P for perpendicular, H for hypotenuse. So sine equal perpendicular by hypotenuse, and curly brown hair, C for cos and B for base and H for hypotenuse. So we can say cos is equal B by H, and turn perfectly blue, T for tan, P for perpendicular and B for base. So tan equal perpendicular by base. And once we know sine, cos and tan, we can easily find the next the other trigonometric ratios, because opposite of sine is cosec. Reciprocal of sine is cosec, so just we make opposite to get cosec, hypotenuse by perpendicular, and from cos we can get sec, just make opposite this to hypotenuse up and base down. So sec will be hypotenuse by base, and opposite of tan is cot, so we will get the formula base up and perpendicular down. So cot is equal base by perpendicular. So okay, now look the right triangle, say A, B, C, where angle B is right angle, and suppose this angle A is theta. Now from angle A we have already said the opposite side we call what is perpendicular, and from right angle the opposite side we call what? Hypotenuse, and the remaining side we call what? Base. So we recall the relation from Pythagoras theorem. So from Pythagoras theorem, geometry, Pythagoras theorem, in a right triangle, so what's the relation we have learned? We have learned hypotenuse square is equal perpendicular square plus base square. Perpendicular square plus base square. So in this triangle, if we write what is the perpendicular, it is AC. So we can write therefore AC square is equal, perpendicular square is what? BC. This BC square, and base is what? AB. AB square. So this relation we have to remember for doing the sums from this trigonometry. And second relation, some more relations you have to know. So some fundamental relation of trigonometry. So already we have said this cosec theta is reciprocal of sine theta, so we can express cosec theta as 1 by sine theta, or this sine theta we can express as 1 by cosec theta. So cosec is the reciprocal of sin theta, and similarly sin is the reciprocal of cosec theta. So we can have this formula: cosec theta equal 1 by sin theta, and sin theta is equal 1 by cosec theta, 1 by cosec theta. And number 3 is sec theta. Sec theta means secant theta. So sec theta is equal 1 by cos theta, 1 by cos theta. The sec is the reciprocal of cos, so we write it as sec theta is 1 by cos theta. And number 4, this cos theta is equal 1 by sec theta. And number 5 is we have this cot theta. Cot theta is equal 1 by tan theta. That means reciprocal of cot theta is tan theta, or we can say reciprocal of tan theta is cot theta. And number 6 is we can say tan theta is equal 1 by cot theta. And there is some more relation we can write here. We can express tan theta as the ratio of sin theta by cos theta. We can express tan theta as the ratio of sin theta by cos theta. And number 8, we can say cot theta we can express as cos theta by sin theta. So this formula also we have to remember. Then there are 8 formulas here, so the fundamental relations. And to see one more point, we take the right triangle here. Suppose this is the right triangle, this is the right triangle. The same right triangle we are taking. Suppose here is right angle, this is our A, this is our B, this is our C. So ABC is a right triangle in which angle B is 90 degree or right angle. Now the angle theta, instead of here, it can be here also. We may need to measure the angle C, that means ACB. So in that case, say ACB is angle theta. And what will be the names of the 3 sides in that case? 3 sides of the triangle. Look here, this angle B is right angle. From here the opposite we call what? Already we have learned that is hypotenuse. Hypotenuse. Now if the theta from A it goes to at C, then from angle C we come to opposite. This will be the perpendicular. This will be the perpendicular, or what we say, opposite side. This point also have to remember. And the third side, this BC will be in that case, what is base or adjacent, base or adjacent side. So in this triangle, see how the name of the sides perpendicular and base are changing. So you have to remember, if angle theta is here at C, then from there opposite side will be perpendicular. That means AB will be the perpendicular, and the third side, this BC, will be the base. And the hypotenuse from right angle, always the opposite side AC. So this point have to remember. So thank you for today, my dear students.